Hello everyone. Welcome again to another educational and informative session from Weinig Holz-Her, coming to you from Mooresville, North Carolina today. I am here with one of our technicians. I'll let Kevin introduce himself to you.
Yeah, as Dan said, Kevin Grimion, Application Specialist here at Holz-Her for the Edgebanders.
What we'd like to talk about today and really explain in great detail is our GluJet glue application system. There are a lot of methods. Well, there's not really even a lot of methods. There's really only two methods in the industry today that are used to apply glue to the panels. Everybody else uses a glue pot with a glue roller. Only Holz-Her uses a GluJet glue injection system, if you would.
Yes.
And is really quite unique. And we would like to clarify exactly how it works today, dispel some of the myths that are out there about how actually people think that it works. Clear up some of the confusion that might be there, and just really in great detail go through this system and show you how it works. We have a system right here in front of us, a little cutaway of the actual glue station. Kevin's going to help us with some of the details about how that works, and you can see inside how it actually heats the glue, melts the glue, applies the glue to the edge of the panel, and then compare that to the glue pot that is so common with the other manufacturers in our industry. So to begin with, I'm going to turn it over to Kevin, and we get started. Kind of talk us through right from the beginning, how we begin, where we start, and how it goes from there. So Kevin, go ahead. Let's get started with it.
Yeah, certainly. We'll go through the whole process from start to finish on how it works and all the different applications for the different glues that we can use.
Great.
So the first thing we have is the magazine chamber here for the cylinder that's going to be pushing the glue. You can either use the pellets like you have over there. We have a pellet hopper, or we have a cartridge hopper. Either one will fit over the station in this position here for us to put the glue. The glue cartridges will fall in the hopper. They'll fall immediately one after the other as it's going. So if we need, as the glue gets pushed in, the next one go in between the panel cycles, it'll automatically refill.
So once you load the hopper with, what, 4 cartridges?
Yeah, you can do 4 total. 1 in the chamber and 4 in the hopper.
Okay, so it'll just automatically feed them, and actually even on the controller on the machine, it tells you how much glue is left.
Yes.
You know when your time, if the hopper's running out, but you have quite a lot of time. It's not like you got to go, oh, wow, hurry up, quick, get another cartridge in. There's a lot of room in there.
Oh, right. And it does it between panels. You don't even realize that another cartridge
has dropped down in there. Okay, good.
Exactly. So the cartridges push forward from the cylinder, and they go right into the waffle here. So let me grab this stick back out of here. And you can see inside, if we zoom in right here at the waffle, that we have a waffle iron there with 5 heaters inside of it. And this is where the glue is going to penetrate the waffle and melt it on demand.
So that's one point that you just mentioned that is really important to highlight, is the 5 heating elements in that waffle heater itself. And that's part of the reason, because from a cold start till we run the first panel through the machine, what is the typical heat up time on the glue?
3 minutes with EVA to get to 200. If we're running PUR, then we're only about 2 minutes.
Right, so 3 minutes from cold starting to running the first panel.
That's right.
Those of you that have a glue pot know what your heat up time is. And part of that kind of goes hand in hand. I know a lot of the, most or all these machines that have glue pots, they never turn it off completely during the day. They leave it idling a little bit at a little bit lower temperature because it takes so long to go from room temperature to operating temperature, which is 15 minutes approximately. Some say 10 minutes. I think the older the machine gets, the longer that heat up time takes. But even at 10 minutes, it's still a long time to stand there waiting for it to heat up. So the heating elements in that waffle heater, that's what helps it come up to temperature so quickly. And the fact, are we going to melt that whole cartridge at one time, Kevin?
Well, no, we're only going to melt the very front of the cartridge here that touches it. So it's a heat on demand.
So only the glue that we need is what we're melting.
Only the glue we need that is melted at the time. So we don't heat and reheat glue constantly. It only melts what we need, and this is why it's so fast.
So we melt it once and we use it.
Right.
We're never reheating in the same glue over again.
That's right.
Right, which is a big point as well, because if you talk to any of the glue manufacturers, their ideal scenario is to heat the glue once and then use it.
Correct.
Because every time you heat and cool, it breaks down the adhesive qualities of and properties of the glue, and it just doesn't stick as well as you'd like it to if it was heated once and applied.
That's right.
Whereas you have a glue pot, you heat all the glue up at once, you run some parts, and then it cools off. And then tomorrow or whenever, you heat the same glue over again. So it could be constantly heated and reheated many times before it's actually used. So that, again, that's one of the big differences between the GluJet application and a glue pot, and that's with the heating of the glue.
Also add to your point is that during a glue pot's normal cycle, when the glue is hot, it's spinning round and round, going up the auger and the glue roller, and exposed to air the whole time that it's hot.
Okay.
And this is also what breaks down the glue.
Right.
It also makes it start to carbonize.
And that's why a lot of times if you look at glue pots, the glue is brown. It looks burnt.
Yeah, so we have a few pictures here.
We have some pictures you can see.
You know, a typical glue pot that has some crusting built up around where the glue is. The inside is starting to create a layer. This can break off, go into the roller, go into the panel. But also you could just see that the glue is deteriorating.
It's very obvious from the pictures. You can see they get pretty ugly, pretty nasty looking. And you can see you want the best bond that you could possibly get with between the glue and the banding, because we don't want any chance that somewhere down the road the bands or the edges fall off. Okay, so we put our cartridge in here, Kevin. It's being pushed up against the waffle heating element. What happens next?
Next here is basically when the panel is going to come in. That's when we'll fully pressurize the cylinder and push onto the glue cartridge that's inside. It'll get melted, go right through the waffle, comes up what we call the dosing rod, the brass rod here. And when the panel comes in and gets to the glue nozzle in the face, the cylinder will open the gate and glue will extrude onto the panel.
I think also there's another heating element up in the nozzle itself. Is that not correct?
There is one right here, and also another thermocouple. And this is to maintain exact temperature. We don't want to rely on just the hot glue coming up and out of the nozzle. We want to make sure it's exactly the temperature we want at the moment of application.
So we pretty much know and can guarantee that whatever we set our thermostat for, that is the temperature of the glue as it's being applied to our board as it passes through the machine.
That's right.
Critical.
That's right. It's very, very critical that we put it on at the exact temperature, because we can control the open time from when it gets to the first pressure roller and where the banding gets applied.
Good. That's a big deal. That's important, because if the glue is applied cooler or colder than the recommended temperature, then it affects the bond and the life of that banding staying on the part. So those are all important features that the GluJet has. Good.
Another point in that is once the glue is melted down at the waffle and up to the extruder, again, we were talking before how it wasn't touching air at the moment. So if you put in white glue, it's going to come out white. If you put in beige glue, it'll come out beige. We can actually maintain the color. It won't burn and start to change color on us. So it is sealed from the air. So this is another benefit of the extruder.
Good. We had received some questions regarding the GluJet and the nozzle. So maybe, Kevin, you could help us understand how this works. If you're familiar, maybe you could take the camera. We could look at the nozzle real close. And you can see there's ridges on the face of that nozzle.
That's right.
And one of the questions is what happens to those ridges? Does glue build up in there? The hole where the glue comes out, does that build up with glue? Explain how that works. And I know there's that's probably one of the areas, or the area with the most questions and most misunderstandings about how that actually works.
That's right.
And we have actually changed the design of our nozzle over the last several years from what it used to be to eliminate some of those problems that we had originally. So maybe explain that to us if you could.
Well, I'll even talk about the original nozzle that had a lot of questions on it. Originally, we had holes that lined up at each of the slots. And with the simple daily maintenance of using a wire brush and brushing at the end of the day, this was no problem. When people don't brush at the end of the day, this is when a problem occurs. It's just a lack of maintenance. Otherwise, the system is impervious to being clogged up.
Okay, great.
Now, it has changed a little bit where we have a full slot top to bottom. As the beam height adjusts up and down, the shoe will go up and down and match the height of the panel. And this will close the top of the nozzle. And then the glue will come out of the slot, get in a striped pattern with the comb on the nozzle.
Nice. I think that's one of the other things that is really nice is that now the way this shoe is literally riding on the face of the panel, just tracing it, because we know melamine is not perfect. It's not 19 millimeters from beginning to end.
Or from brand to brand. It might be a little bit different, or plywood.
Right, it changes. So the nozzle is going to open or close with the variations of tenths of a millimeter in the board thickness, so that we always have just the right amount of glue for the thickness or the width of the board that we're running.
That's correct. That's correct.
So it takes the operator out of it.
Yes.
You didn't have to worry about setting it properly. And
that's right.
So we always have glue covering the entire face of the board.
Along with that is the volume of glue. So if we have an MDF panel, it's pretty closed. We don't need a lot of glue. If we have a chipboard that's very open, that has a lot of pores in it, then we need a little bit more glue injected so we can reach in and grab all the parts. So we'll change the air pressure on how hard we push the cartridge in.
Okay.
And just like a hot melt glue gun, the harder you pull the trigger, the more glue you get out.
Right.
Very easy. So on the controller, we don't even have to use a knob, but on the controller, we can change the air pressure that we're applying, and therefore how much glue is going to come out into the panel.
Okay. Wow, that's easy. Real simple. One of the other questions, or one of the common things that we hear, is in regards to changing the glue. If I want to go from white glue to a different color, opaque, whatever it might be, what's the process for doing that, Kevin? How's that work?
Yeah, so you have a couple different options. The first one is, as the glue is getting melted here, we can actually open the hopper. We can pull out the melted cartridge. It's only melted in the front. I can pull it out, switch it out with a different color, start the process. We have a one-button press where we can press on the controller. It'll start to purge the glue out of the purge port in the bottom here, and until the new color comes out, usually just a couple minutes, and then we're ready to run with a new color.
What about that old cartridge that you took out? Can you reuse that, or is that wasted and you just have to throw it away?
No, if it's EVA, then we can certainly reuse it later, at a later date.
Okay, great.
Not a
So
problem.
it's real simple, very easy, so we're not wasting that glue.
Correct.
Right. Any of you that have cleaned a glue pot know that it's virtually impossible to take that glue that's in there and take it out, clean it out, and reuse it. That's just not going to happen.
Or try to go from white to black, or black to white. Yeah. So we can actually go a complete switch with the color of glue without a problem.
Yeah, most people that I've ever spoken to that have used glue pots just don't change the color because it's too difficult.
Right.
Even if you could, it takes a long time.
Yes.
A long time, like maybe an hour or so to get all that glue out, put a new color in there, run it till it's all pure and you have the new color coming out. You just wouldn't do that. It just takes too long.
So I mentioned two options. So the first option is to remove the cartridge and go. But like you said, we have a meter on the controller that will tell us how much glue is remaining in the system. So I can simply run out. Let's say in this case it's a translucent glue. So I can watch the meter and I know when it's coming in, and I've only have maybe 10 or 11 meters left. I can then have the next color behind it and just wait to that moment in production and purge, and then switch to my other products.
The nice thing about this meter that Kevin's talking about on the controller is that it actually tells you, as he mentioned, how many meters of banding are left in the cartridge that's in there.
Yep.
And that even changes with the thickness of the panel. So if I have a 19 millimeter panel and I change to a taller or a narrower piece, the meter will change accordingly because it knows if the part's taller, I need more glue. If it's smaller, I need less glue. So it's automatically compensating, and you can just look at the controller and know how much glue is left with that cartridge.
That's right.
And then time and judge when to change it.
That's right. We try to make it as easy as possible for the operator and as versatile as possible.
Right. So one of the other big benefits of a Holz-Her glue system with the GluJet is the ability to run PUR glue.
That's right.
Without any addition, without any modifications, without any accessories added to the glue station. We can use the same glue station, the same waffle heater, the same nozzle. We just use the PUR cartridge. So Kevin, explain to everyone, show us how you would run PUR glue on this system that we have. Because what you see right here in front of us is the same glue system we use on virtually every model of Edgebander that we sell.
All the machines, yes. The great thing about the GluJet, made for the larger applications, but it's brought down to the smaller machines as well and used in those machines. So whether you run a 2 kg glue cartridge for the larger station applicator or the standard cartridge here, we can run PUR in either one. So in this case here, we would put the PUR in and we would purge it.
And it comes in a cartridge just like that? Anything different?
Yes, no, it's the same one. This is actually a PUR cartridge here.
Okay.
That we have inside here. It's obviously it's set up already.
Explain how they come from the manufacturer and why they are in the containers like they are.
Yeah, so PUR is a polyurethane glue, but it has a reactant in it. So once we open the can, we have about 8 to 10 hours, depends on the manufacturer's time, that it will start to cure. And that's the R of the PUR. It's the reactant.
Okay.
So
right there you said one thing that's really important that I think this is a big myth in regards to just PUR in general is the time frame. Kevin just said you have 8 to 10 hours. So that's important to know because if I'm running a PUR glue cartridge, I can go to lunch, I can take a break. I don't have to worry about it hardening in the system.
No, we let it cool off, go to lunch, go to break, no problem. Go on the forklift, do what we need to do, and then come back and start working with the machine again.
Good.
So we're not going to open 10 cans in the morning. We're only going to open maybe 5 or 6 that we need until lunch, and then maybe after our lunch break, we'll open a few more.
Right. And then as you get to the end of the shift or the end of your production run, you're watching the meter on the screen. You know how many meters of banding are left with the cartridge that's in there, and you can time it based on what production you have left to run. So I don't open up a cartridge, stick it in there, then barely use it because unlike the EVA, if I don't use that whole PUR cartridge and I go home and come back tomorrow, then that cartridge is I just have to throw it away. I have to discard it.
Basically like mixing cement in a wheelbarrow. So once you're done, you need to do it in batches. So we have the cartridges in the can, just like the batches. And at the end of the day, we need to rinse it out.
Good. So one of the big questions is how do we rinse this system out? How do we purge all that PUR out? We don't want to leave it in there overnight, over the weekend, and come back in on Monday and, you have a boat anchor now.
That's right.
So what do we do in regards to that?
So each manufacturer of PUR is going to have a flushing agent. So whether it's a GluJet or GluePot or Doris, whichever one it might be, they're usually a different color. And this is not just a color to know once it purges, but also it's a deactivator. It's a neutralizer. So once it mixes with the melted PUR, that PUR that's in the system, if we don't get it all out, there's a couple 1 to 5% left over, it's not a problem. This will prevent it from setting up, and then we can wait a whole week. And once we turn on the glue station again, it will heat and reactivate that glue, and we can purge it.
Okay, so that brings me to one of the other questions that somebody had asked is, well, why can't I just take another EVA cartridge and put it behind the PUR cartridge and purge the system? Can I do that?
No, certainly not. And that's what I was mentioning was the neutralization. So you must use a neutralizer for the PUR. So this would go with this one, and this goes with this guy.
So once the cleansing cartridge comes in contact with the PUR, then it neutralizes it. It can't harden anymore.
That's right.
And if there was a little bit left in the nozzle, it's not going to hurt anything.
Yeah, and to demonstrate that, we have a little video clip here we can put in. So we'll play this video for you guys, and you guys can see how we're going to place the red cartridge in. In this case, we're using a GluJet glue. They're going to put a single load hopper back on. It's a 1-button press, and the glue will start to purge. There's a purge port on the lower part of the nozzle, and this is where the glue is going to come out until, in this case, it went from white to red, and we're good to go. So now we know that this is fully purged out. It's neutralized anything that's remaining in the waffle, and we're good.
Nice. That's good to understand how that works, because some of these things it's really hard to see, especially if the station is mounted up in the frame of the edgebander. It's hard to get in there and get a good view of it. So that video is a great explanation of how it works.
It's right here in the front, and there's a catch bin that goes inside the machine to catch the glue coming out, the remainder of the glue and the purging agent. The next morning we would just put PUR in, and purge it until we have glue coming out.
Okay, yeah, you can see the color differences.
EVA, whichever one we might want to go to the process.
And that process takes minutes.
Yeah, just a few minutes.
Like 2 or 3 minutes to do that, right? So it's very simple, very quick, and it's real easy to go back and forth from either back and forth from PUR to EVA, EVA to PUR, no problem, or just PUR to PUR from day to day to day without a lot of time and without a lot of effort in it. Good. In regards to PUR, one of the common things that I hear, one of the questions somebody asked us prior to this presentation was, what about off-gassing in PUR glue? We know that that's a concern and that's a reality. So can you explain what the ramifications are of that with the Holz-Her GluJet?
Yeah, that's a great question, and it's been asked many, many times. So the PUR, when it's being melted inside the waffle, is self-sealing here in this area, so we have no off-gassing here. And we don't have the roller spinning around in the open air, so we don't have any off-gassing in this case either. The only time the glue is exposed to air is after it's applied to the panel until it gets to the pressure roller. It's a very short amount of time and a very low volume of glue. We've actually had companies come in to measure the system with sniffers, and they actually have had no readings. So we have a very short open time. Because our nozzle is very thin, so our approach angle is very small, and we have the closest distance to the pressure roller. So only the glue that's on the panel from the nozzle to the roller is the only time it's open.
So it's so small, so minimal, there's really nothing to worry about. One of the other questions we have is someone wanted to know, well, does PUR work for all types of edge banding, or is it only limited to PVC or whatever?
No, actually, that's one great thing about the PUR application. Is it bonds to some materials that EVA will not. So it is a much better bond. It's a much a thinner bond as well, because the viscosity of PUR and EVA are much different.
That brings up a really good point, Kevin. Something that we want to explain and clarify for everybody is the thinner bond. I know you and I recently did a demo with a customer here in our showroom, and we ran the PUR glue, and the customer was just absolutely blown away with the literally invisible glue line. He could not physically determine where the banding stopped and the panel began. It was that thin, but it was a tremendous bond.
I think his comment is, it looks like it grew that way.
Right, that's what he told me. Yeah, he accused us of having one solid piece of plastic or whatever, because he couldn't tell that there was an edge on it. He thought we just put a little radius on the corner of the board, but it was that thin. And we have a video, I think.
Yeah, we do. We have a nice little clip here that shows you your comparison of viscosities.
It really explains well the difference of the PUR compared to the EVA.
That's right.
And why we get a thin glue joint or no glue joint, but we get a great bond, and this is the video.
So this is a great comparison. Something that everyone can relate to is honey. Everyone loves honey. So if you spread honey on a bread, you can see how the viscosity is very thin. It likes to go into the pores. Conversely, Nutella. I mean, we all love Nutella, but in this application, not the best way to go. It's a very thick material, similar to the EVA. And from here we can see that once it's spread out and we place them together, the EVA will have a lot of viscosity.
Right, and there's a lot of squeeze out there.
And you have a thicker glue, so it can't bond so thinly. And a lot more squeeze out. In the way of the PUR, it takes less glue, and we don't have the squeeze out. So this is why, since the viscosity is so thin, we can really get a tight seam.
And it's absorbed into all those pores.
That's right.
Actually better than the EVA because the viscosity is so much lower.
Correct.
And so it goes in all the pores, gets a really good bond.
That's right.
Also, one of the other real benefits of the PUR glue is the heat reaction that it has. Explain.
It's heat proof.
Right. So there's once PUR glue has cured, it's not like you can heat it back up again and it's gonna fall off. Correct?
Absolutely not.
It's permanent.
It is permanent. It is permanent. Once it cures, usually it's 1 to 2 days, depends on the environment. Because actually the moisture in the air and in the panel is what cures the glue. And again, it starts 8 to 10 hours from once you apply it. And once this bond is fully cured, then it is impossible to heat it up again. And the bond just increases over time.
So one of the things I want to make sure that everybody understands is it does take 24 hours minimum to cure completely.
That's right.
But as soon as it comes out of the Edgebander, it's still got a pretty good bond. It's not like your edges are going to fall off.
It's the same as EVA. Once you apply it, and if you were to take the banding off at the back of the machine, you would have a very, very same comparison to EVA.
Right.
It's just going to get stronger and
That's
stronger
the
as
difference.
time
Over
goes on.
time, over 24, even 48 hours, the bond is going to get even better.
Even better.
Right? Because I think a lot of people have experienced. I talk to people all the time. They did a job. They put it in a tractor trailer. They shipped the parts, the cabinets, to some hot environment, Arizona, wherever it might be.
Yep.
They sat in a truck. They went to install the cabinets, and the glue reactivated because it wasn't PUR, and the edges were falling off when they were installing them, and it was just a huge problem. So that's a real benefit of PUR. What about moisture?
Yeah, because the bond is so tight, and once the PUR is cured, it becomes a plastic itself, and therefore moisture cannot penetrate.
Right. So in moist environments, I think of like locker rooms and things like that, where there's a lot of moisture in the air, the edge banding that's been applied with the PR is not going to be affected by that. It's not going to come loose or
That's
fall.
right. That's right. Because of the heat proof, it's going to be a tighter seal, a tighter bond, and therefore no place for the water to penetrate.
Good. I
Exactly.
think it's important while we've been talking to want to give a shout out to a fellow employee of ours, Mike Sigmund.
Yeah.
Mike has been a big proponent of ours, and
That's
I
right.
think he might even be watching.
Yep.
So Mike, next time you can join us on the video.
Yeah, we missed your presence. But you'll be here next time.
Yeah. So maybe in conclusion, Kevin, what are some final comments we want to make to wrap this up and let people make sure they have understood exactly what we're talking about, and certainly hopefully you've seen some of the benefits.
Yeah, I mean, I think that the ease and the versatility kind of speak for themselves.
Right.
I hope we explained everything adequately. If not, please leave some comments.
Yeah, you can always, we post the videos out there. We'll be reviewing them. You watch it, and if you have questions, put them on the comment section. We'll be glad to answer them. But hopefully, as a result of what we've done here this morning with you, that you get a better understanding of the GluJet and how it really works compared to what you may have been told by someone.
Right.
Now you can see it yourself firsthand. The cartridge, whether it's EVA or PUR, is very easy. We can change the colors quickly. We can heat it up quickly.
That's right.
We don't have to be worried about PUR hardening over lunch or taking a break. We've got time to work with it.
Very easy.
I think in one other note, Kevin and I had this customer that Kevin and I worked with. They were running 20 hours a day.
Yes.
So they want to run PUR. So at the end of the shift, they only have 4 hours before the next shift come in.
Right. So they only flush on Fridays.
Right.
They come back in Monday, load the PUR in. As you say, they're actually running such a high volume production.
Right.
Instead of opening, 10, 20, 30 cans a day, they're only opening 4 of these.
Correct.
Because these are about the equivalent of 8 of those.
So we have different
And then it can go
options.
immediately from one shift to the next.
Yep.
Yes.
So we have different options, because if you're running a high volume of PUR like this customer was, 20 hours a day, use the large 2 kilogram.
Large 2 kg,
Yeah.
it's much, much less expensive.
Much saves money, and you don't have to change the glue swab. So a lot of good things, a lot of good information. I trust that it's been educational to everyone and beneficial. Hopefully now you got a true picture of how the GluJet works. Kevin, thank you for all your technical knowledge and assistance. And if you have questions, put them in the comments. We'll get back to you. And thank you to everyone for watching another session from us here at Weinig Holz-Her in Mooresville, North Carolina. Have a good day.
Thanks.